So far, we've been treating light as a wave. We have been using wave characteristics and wave magnitudes applied to light. We have said that the light has a wavelength or a wave number, which is the inverse of one another, right? Or we have said that the wave has a period, which is the inverse of the frequency. So wave number, period, frequency, wavelength, these are all properties of waves. However, at the turn of the 20th century, there was an experiment that didn't match with the understanding of light being a wave. And that experiment is called the photoelectric effect. Its interpretation is due to Albert Einstein, and because of that, Albert Einstein got the Nobel Prize. It's ironic that Albert Einstein didn't get the Nobel Prize because of the theory of relativity or many other contributions to science. It was to a specific area in which he was not very fond of. We will talk more about that. But this principle of this experiment that proves that light can behave like a particle is that sometimes when you irradiate light on a piece of metal, sometimes that light, if it's energetic enough, it will kick some electrons out. Okay, if this happens in this evacuated chamber, these electrons can go to the other side of the circuit and then imply or measure some current. So the idea is that by irradiating light you can create a current. The question is, what kind of light can you irradiate this piece of metal so that you can create current? Okay, so that you can pull out electrons and create electric current. What they saw is that there is a minimum energy to pull out electrons. So something that is characteristic of waves is that if you increase the frequency or increase the intensity or amplitude, you can pull out electrons. So this means that if you were to take infrared light and you increase the amplitude, that would be as if that became as energetic as X-rays to some extent. Okay, this is that would be the behavior of waves. However, that's not the behavior that this experiment shows. The experiment shows that only through frequency, not through amplitude, you can create current. Let me give you a practical example. You may have heard that cell phones or microwaves can be damaging for our health. But as you have learned before, cell phones, for example, deal with radio waves, waves that have very little energy. The assumption that an accumulation of radio waves can make the light have increased energy contradicts the experiment of the photoelectric effect. So this more than 100 years old experiment contradicts the conception sometimes that microwaves and cell phones can be damaging for your health because of those waves can amplify each other and become like X-rays. That is not correct, because what we saw is that the energy of the light depends exclusively of the frequency. If your frequency is low, such as microwaves, there is no way that you can make that light energetic, regardless of regardless of the amplitude of that light. So that's a little bit the take-home message, that light has to be then made out of particles, because particles do not amplify each other. Okay, so that was the very conclusion that Albert Einstein came up with, and it's simple enough to have a very simple equation in which this new particle of light, it's called a photon. Okay, and this photon has an energy equal to a constant times its frequency. This constant is called the Planck's constant due to Max Planck, and it's very tiny. Okay, but this means that this is the energy of one photon, and the energy of two photons of this frequency is just this times 2. Okay, So, let's do an exercise. For example, what is the energy of 3 photons with a wavelength of 300 nanometers? First of all, the energy is the Max Planck constant times the frequency. We're given wavelength, we're not given the frequency. So what we know is that the speed of light is the wavelength times the frequency. This means that frequency is equal to the speed of light divided by the wavelength. So there you go, c divided by wavelength. So we just need to substitute now, because we know everything else, two constants and the wavelength, c 34 joules per second. Now the speed of light is a constant in vacuum, 3 times 10 to the 8 meters over second, and the wavelength, 300 nanometers, is 300 times 10 to the negative 9 meters. So 300 times 10 to the negative 9 meters. Okay, and if we did this right, meters and meters, seconds cancel with seconds, and this will be joules, and that would be the energy of 1 photon. The energy of 3 photons will be the energy of 1 photon multiplied by 3. Okay? Hopefully that makes some sense.